Today I would like to introduce U1mA Power ZGF series integrated DC high voltage generator. The instrument adopts an integrated design scheme. The doubler and the main engine are placed in a case. The instrument has completed protection functions with zero protection, over voltage protection, over current protection, breakdown protection. Select nanosecond special sensor for protection circuit. Fast and reliable action to effectively guarantee personal safety and equipment safety. Conduct DC withstand voltage test and leakage test of zinc oxide arrestor, magnetic below arrestor, power cable, transformer, generator, and other equipment. Today we will take a ZGF 120 kV 2 mA DC high voltage generator and the zinc oxide arrestor as the test products. Let's have an experiment. Now let me introduce the wiring of the equipment. In order to ensure equipment and personal safety, the instrument should be well grounded. First, we connect the grounding pile to the ground wire. Then connect the power supply to the device. Then we connect the end of the instrument with a special medium frequency data lamp provided by the instrument. One end is connected to the medium frequency output of the instrument, and the other end is connected to the input port below the doubler. Microammeter is connected to the top of the player doubler. Connect the special high voltage wire on the upper part of the microammeter. The other end is connected to one end of the zinc oxide arrestor. The other end of the zinc oxide arrestor is grounded. The grounding of the doubler shall be well grounded. After this connection is made, we need to connect the discharge rod of the instrument to the ground wire. Set aside for later use. After the instrument is connected, I will explain the operation of the instrument for you. We can first look at the instrument with an over voltage setting. It means when your voltage exceeds your over voltage setting. This instrument will trap. You can adjust the over voltage setting value according to their own needs. The highest voltage of this instrument is 120 kV. Let's just set it to 120 kV. Then we turn on the power switch. This instrument has zero protection function. This means that the voltage will not turn on when your voltage is not at zero. The high voltage generalizer will only light up when your voltage adjusting knob is back to zero. Then can output high voltage to this instrument. Okay, let's test the breakdown voltage and leakage current of this zinc oxide arrestor. First, we adjust the voltage to zero. Then click on HV path. Then we can look at the voltmeter and turn the voltage adjusting knob. Give this zinc oxide arrestor a boost. While looking at the voltmeter, we can look at the ammeter here. When the current reaches 1 mA. At this time, 18.5 kV is the breakdown voltage of the zinc oxide arrestor. At this time, we click the button of 0.75 times UA again. This is the leakage current of zinc oxide arrestor at 0.75 times voltage. That's 0.003 mA. We return the voltage knob to zero. Then click the high voltage off, cut off the power, cut off the output, and then turn off the power. After we turn off the power, we discharge the zinc oxide arrestor with this discharge rod. By this time, we will have finished our experiment. The breakdown voltage of this zinc oxide arrestor is 18.5 kV. Its leakage current at 0.75 times voltage is 0.003 mA. Special attention is required. The instrument and the tested product should be well grounded. When doing capacitive load test, it is necessary to connect current limiting resistance. After the test, discharge the instrument and the subject will discharge load. Other operational and experimental methods are not described. For more information, please visit the official website of Huatian Electric Power Co. Limited, www.hvtest.com.